Okay, ladies, we are going to do lesson 5.6. We're going to start in your spiral with the explorations, and then we will do a toolkit entry, and then with whatever extra time we've got, do some extra practice back in your spiral. So right now in your spiral, if you're someone who likes to label your lessons, this is 5.6, graphing linear inequalities in two variables, and those two variables are x and y. So no major surprises there. Okay, so let's get into this. A solution of a linear inequality in two variables is an ordered pair, so we're looking for an x and a y, that makes the inequality true. So this is not different from anything we've been doing before, except now we're talking about inequalities versus equations, so that's where there's a slight difference. The graph of a linear inequality in two variables shows all the solutions. That's important, and you don't need to be writing this down. But the graph shows all the solutions on a coordinate plane, and we're going to talk about what that means in a second. So in this first exploration, take a second to do part A, write an equation represented by the dashed line. So pause the video and try to write the equation just of this dashed line here. Okay, you can tell by looking at this graph, the line is rising, so we know we're going to have a positive slope. And that slope is going up 1 over 1, up 1 over 1. That slope is 1. And its y-intercept 3. So the equation of that line is y equals x minus 3. Excuse me, that was negative 3. Okay, part B, the solutions of an inequality are represented by the shaded region. So all of this down here represents the solution. In words, describe the solutions of the inequality. In this lesson and in the next lesson, we're going to be talking about things that are like above the line or below the line. So in this case, that shaded region is going to be all of our solutions. So the solutions of the inequality are all the ordered pairs below the graph of the line. Write an inequality represented by the graph. Which inequality do we use? Explain your reasoning. Okay, so we've got this equation, y equals x minus 3. And we know that that whole area that I highlighted is where the solutions are, because that's what we told you. The shaded part is going to be where the solutions are. So to figure out which way the symbol should go, we kind of need to test a point. So you can choose any point or any ordered pair that's in the shaded region. I'm going to go ahead and choose 4, 0, just because it's easy. So what we're going to do is we're trying to figure out which way this symbol should go. So I'm going to take my equation, but instead of equals or less than or greater than, I'm just going to kind of leave a space there. Y something x minus 3. Okay, my y value is 0. Again, you could choose any ordered pair in that shaded region. My x value is 4 minus 3. 4 minus 3 is 1. Okay, so now we need to figure out which inequality symbol do we need to make this true. 0 is less than 1, so I'm going to change the symbol to be less than. So my inequality should be y is less than x minus 3. And something you'll start to notice is when it's shaded below the line, it's going to be y is less than, or less than or equal to. We're always going to test our point. So that's how we wrote the line. Okay, using a graphing calculator, take a minute to write down this inequality so that when I change screens, you're okay. Y is greater than or equal to 1/4 x minus 3. And what we're going to start with is by putting the equation into your line. So we're going to start with doing y equals 1/4 x minus 3. So let's go down here. And I've already typed in my equation. Remember, I pressed y equals 1/4 x. Don't forget you're using that button next to the alpha button, minus 3. And you might not have noticed before, but you have these different kind of symbols here on your graph. So I'm going to go ahead and switch it back to what it's been on before. And we can always look at our graph here. So that's your line. That's what we saw before. But as you might have seen a second ago, I just changed some of those settings, and I'm going to show you how to do that too. So click your y equals again, arrow back over, and notice I'm going to the left of y1. It doesn't matter whether or not you have a colored graphing calculator or not, you still should have this option. Go ahead and press enter. And then you can mess with the color, but that's not what we care about right now. We're going to go down to where it says line. And you can toggle using your arrows. See how it's flashing to use your arrows to have different types of boundaries. So in this case, the inequality was y is greater than or equal 1/4 x. And so let's go with our gut and say that we think it's going to be above that line. So you can see that shading, it's going to have shading above. So then arrow down to OK and press enter. And now we can see our graph. And it's actually going to shade it for you. So what if you weren't sure about whether or not you had it above or below correctly? So let's test that to make sure we did it right. An ordered pair that's in this region, any single ordered pair, if we shaded it right, if we told it to shade above or below correctly, should make your inequality true. So let's choose an ordered pair to test this. My favorite ordered pair to test is the origin, if it's in that shaded area, because it's so easy to plug in. So let's go back here. We have our inequality symbol, and as it says here, we're going to test 0, 0 in our inequality. So I'm going to do 0 because that's the y value is greater than or equal to 1/4 times 0 minus 3. 0 is greater than or equal to 1/4 times 0 is 0 minus 3 is negative 3. 0 is greater than or equal to negative 3. Is that true? Yes, that means it checks. So that means that when I told the inequality to shade above, that was correct. So again, remember I mentioned that if it was less than or equal to, we were going to shade below. That was up here. And again here, when it's y is greater than or equal to, we shaded above, slightly darker. One thing to notice is that sometimes, not sometimes, on your graphing calculators, the boundary line, this thing, it is not going to distinguish when you're shading whether this boundary is solid or dashed. So you kind of have to pay attention to that yourself. Okay, let's get into the toolkit. Take a minute, put your title in your table of contents, label your page, you know the drill, and then come back once you're ready. We've got the definition here. A solution of a linear inequality in two variables is an ordered pair, x, y, that makes the inequality true. All right, our first type of problem that you're going to see on your assignments is just determining whether or not it is a solution. This is just like it was when we did 5.1, where we just plug in our ordered pairs to see if it makes it true, except this time they're inequalities. So I'm going to do 3 times -1, that's my x value, minus 4, the 1, and 6. 3 times -1 is -3, plus 4, 6. -3 plus 4 is going to be 1, which is greater than 6. Is 1 greater than 6? No, it's not. So this is not a solution. All right, next one. -x minus 2y is greater than or equal to 5. We have the ordered pair of -2, -3. So we have the opposite of -2, because this is this, and then whatever x is -2, minus 2 times y, which is -3. We've got a lot of negatives going on here. The opposite of -2 is 2. -2 times -3 is +6. 2 plus 6 is 8, which is in fact greater than or equal to 5. So yes, that is a solution that makes it true. All right, now we're going to get into the most important part of this lesson, which is graphing the inequalities. There are a lot of steps here. If I were you, I would take a minute to just jot it all down and then come back and listen to my explanation. The first thing we're going to do is graph the boundary line. When I say boundary line, that's the limit. That's what it would be as if it were y equals 2x plus 3 or x equals 5. So you're just going to graph it as if it were an equation. There's one exception. If you have less than or greater than, you're going to use a dashed boundary line. That's because the things on the line are not actually solutions to the inequality, because it doesn't say can equal that value. In contrast, if you have less than or equal to or greater than or equal to, those are going to be solid lines, just like you've been doing all year. And that's because the points on the boundary line are solutions to the inequality. So those are included in your solution. Then we're going to test a point, either above or below the line or to the left or the right, depending on what your graph looks like, to find the area that makes the inequality true. And then we're going to shade. Okay, so this is going to be number 3. 4. Okay. Y is greater than -1. This is going to build on our ideas from chapters 3 and 4. So -1, y is -1. So I'm going to graph that. Things I want you to notice straight away. This is greater than. That means it's going to be a dashed line. Okay, and we're going to go to the y value of -1 and draw a dashed line. And then we're looking for the y values that are greater than -1. Well, we think that should be anything above, so let's choose an ordered pair. Let's choose 0, 0. Actually, I'm not going to graph that. But we're going to test 0, 0. Well, don't let this confuse you. You only have a y value. So is 0 greater than -1? Yes, so that checks. What I would suggest you do is use a highlighter or a colored pencil or something, and you can just highlight the area above it. Sometimes what people like to do also, another option, is you can kind of do some stripes, but make it really clear that it's everything above that line. Either one's fine. Okay, number 4. Y is greater than or equal to 2x plus 3. Okay, this has an equal to, which means it's going to be a solid line. We graph our boundary line. Here, my M is 2 and my B is 3. So I'm going to start at the y-intercept of 3. I go up 2 and over 1. Well, I can't go very far in that direction, so let's go the other way. Down 2 and back 1. Down 2 and back 1. Down 2 and back 1. And again, we said it's going to be a solid line. Okay, this gets a little tricky. Y is greater than, so it should be above the line. So I think that means it's going to be, don't highlight this, I think it's going to be over here because that's kind of on top of the line. But we want to check. So let's choose an ordered pair that is on that side that I shaded. Let's choose -3, 0. So I'm going to put that into my equation, inequality rather. 0 is equal to -3. -6 plus 3 is -3. 0 is greater than -3. That is true. That checks. So what that means is that you're going to use your highlighter to highlight the whole region that is on that side. Or again, you can do some sort of stripes. Okay, this equation is not in a y equals setup, so I have to solve for y first. So I'm going to rewrite it over here on the side. I'm going to add 2x. -3y is greater than 2x plus 6. Divide by -3. Now here's a reminder from chapter 2. When you divide by a negative in inequalities, you have to change the sign. Those rules are still true here. Okay, so my m is -2/3 and my b is -2. So I'm going to go down 2 and over 3 and go up 2 and back 3. And this time it's not equal to it, so we are going to use a dashed line. Arrows. Okay, and what I'm going to look at here for my shading is here. Y is less than or equal to, I'm sorry, less than -2/3 x minus. So things that are below the line is going to be something we want to test. So I'm going to test 0, -3 because that's below the line. You can plug your point in either to the original inequality or the one that where you isolated y. It's really up to you. I'm going to do it in my y equal, or y is less than. So -3 is less than -2/3 times 0. This is why I like using zeros. Things will simplify. -3 is less than anything times 0, 0 minus 2. Is -3 less than -2? It is. So that checks again. So then highlight, or you do stripes, whatever, something to shade this region. That's how it goes. All right, so that's everything in your toolkit. Now let's go back to your spiral for some practice for those word problems. Just like we've been doing recently, you don't need to write down every single bit, so we're just going to read the problem. An online store sells digital cameras and cell phones. The store makes $100 profit on the sale of each digital camera, X, okay, it's already defined our variables, and a $50 profit on the sale of each cell phone, Y. The store wants to make a profit of at least $300. Do you see that vocabulary again? Selling both of the cameras and the cell phones. Write and graph an inequality that represents how many digital cameras and cell phones they must sell. Okay, and then we'll get into the last part, identify and interpret two solutions. Your homework will have. Okay, so they already defined our variables for us, like I mentioned. We can go straight into writing our equation. We get $100 of profit for every camera, and they said that was X. Plus, we're going to get $50 for every cell phone, was Y. And we need that to be at least, so that means it's going to be greater than or equal to $300. Now, this might look like a pain to graph, but we're going to isolate Y. Divide by 50, divide by 50. Y is greater than or equal to negative 100 divided by 50 is just negative 2x, plus 300 divided by 50 is 6. So manageable. Okay, my y-intercept is 6. Down 2 over 1, 2 over 1, 2 over 1. All right, and it says y is greater than. So let's test something. I'm going to test 6, 0, which is over here. So 6, 0 is what I'm testing. 0 is greater than or equal to negative 2 times 6 plus 6. 0 is greater than or equal to negative 12 plus 6. 0 is greater than or equal to negative 6. Is that true? Yes. Or you could do a check mark, it doesn't matter. So anything that's true is going to be anything that is above that graph. Don't worry about getting right up the line, as long as it's very clear. Okay, so that's our graph. And then it says identify and interpret two solutions of the inequality. Don't overthink this. This is basically saying choose two solutions, so any two ordered pairs in that shaded region. And then when it says interpret, it means tell us what it means. So let's choose any two random ordered pairs. It doesn't even matter. So let's do this one. This is 6, 3, and that is 7. So what that means is you could have 6 was my cameras. You could have 6 cameras and 3 cell phones. That would make a lot of money. Or you could have 1 camera, that's my X, and 7 cell phones. There's an infinite number of ways you could choose, but that's kind of the example. All right, next one is giving you a graph and practicing writing your equation like we did at the beginning of class. So let's look here. My y-intercept is at negative 1, and my slope is falling. And I can see here it has another point. So that's at negative 1. So it's a little bit hard to see on the right side, so let's go to the left. We went up 1, and then back 3. So that's going to be a negative 3. So that means my slope is negative 1/3. Also notice that this is a dashed line, so it's not going to be equal to, and then it's shaded below, so it's going to be y is less than. Y is less than negative 1/3 x minus 1. Let's check to make sure our symbol is in the right direction. You have a couple choices. I would choose an ordered pair that you know is going to make it true, or it should make it true. So 0, negative 2 will work. Again, any ordered pair. Let's test 0, negative 2. So negative 2 is less than negative 1/3 times 0 minus 1. Negative 2 is less than or equal to negative 1. That's true. So we wrote our inequality correctly. All right, one more word problem. You can spend at most $9 on potatoes and carrots. Potatoes cost $3 per pound. Define our variables of P equals number of pounds of potatoes. And carrots, which is the other thing we don't know, number of pounds of carrots. They're $1.50 per pound. Write and graph an inequality that represents the situation. Okay, so we can send at most $9. That means $9. So that means the money that I have is going to be less than or equal to 9. My potatoes are 3p, and I can do carrots at $1.50 times my carrots. We can decide which one's going to be our x value and our y value. I'm going to treat potatoes as x and carrots as my y, but it doesn't matter. Okay, so if carrots are like my y, I'm trying to get c by itself. So I'm going to subtract 3p from both sides. 1.5 c is less than or equal to negative 3p plus 9 divided by 1.5. C is less than or equal to negative 3 divided by 1.5 is going to be 2p plus 6. Again, this is like your y and this is like your x. So now we can graph our potato situation to this is p for potatoes and c for carrots. And my slope was negative 2, so I'm going to go down 2 over 1, down 2 over 1. Get my ruler. And it was equal to, so it's going to be a solid line. And it was less than, so this time it's actually going to be below. That's what we think, and we can always test that to make sure it's true. And 0 would be below, so we can test 0, 0. 0 is less than or equal to negative 2 times 0 plus 6. 0 is less than or equal to 6. That's true. And then again, it says identify and interpret two solutions to the inequality. Anything in there works. So you could do 2, 0 right here, which means you could have 2 pounds of potatoes, and no carrots. Or we could do this guy. So that way we could do 1, 2, which would be 1 pound of potatoes and 2 pounds of carrots. Again, anything in that shaded region.